Question 1. In light of recent developments, Mr. Alvarez is tasked with troubleshooting a negative pressure isolation room that is unexpectedly maintaining a slightly positive pressure relative to the adjacent hallway. The room is used for airborne infection isolation and includes HEPA filtration, anteroom access, and automated pressure monitoring. Upon inspection, all supply and exhaust dampers are functional, but the building automation system BAS trend logs minor fluctuations in exhaust fan speed during peak facility demand. What is the most critical corrective action Mr. Alvarez should take to restore proper pressure balance? A. Increase the supply airflow rate by 15% to match demand fluctuations. B. Add additional HEPA filters to increase exhaust pressure drop. C. Coordinate with facilities to prioritize constant exhaust fan speed through BAS control logic. D. Adjust the anteroom pressurization to create a larger buffer zone. Answer. Correct answer. C. Explanation. ASHRAE Standard 170 mandates that airborne infection isolation rooms IS maintain negative pressure relative to adjacent areas at all times. Variable exhaust speeds can undermine this balance. Increasing supply A further worsens pressure. Adding filters B increases resistance without solving root cause. Buffer zones D help but do not solve exhaust instability. Solution C ensures constant negative pressure through stabilized exhaust rates. Facilities coordination to lock the exhaust fan speed is aligned with infection control protocols, minimizing airborne pathogen escape. Question 2. The underlying principle of maintaining a surgical suite's HVAC system is rooted in precise environmental control. During scheduled system inspection, ISQUAN notices that the US dew point is trending above design set point even though temperature and RH readings appear normal. Which of the following best explains the elevated dew point and its potential implications? A. Fault in the return duct. Static pressure control is causing backflow from adjacent rooms. B. The reheat coil is underperforming due to control valve malfunction. C. The desiccant dehumidification wheel is operating at suboptimal regeneration temperature. D. Or air changes per hour which have been increased to compensate for pressurization. Answer. Correct answer. C. Explanation. In ORS, dew point control is essential to inhibit microbial growth and maintain sterile conditions. A faulty desiccant wheel C causes poor latent heat removal even RH and temp seem acceptable, leading to high dew point. Static pressure A affects airflow, not dew point. Reheat coil B impacts temperature post dehumidification but not dew point directly. Its changes D affect airflow, not moisture content. ASHRAE 170 and FGI guidelines emphasize proper dehumidification strategies for ORS. Question 3. By evaluating the results of a recurring issue in a hospital's HVAC system, Mr. Daniels observes intermittent shutdowns of variable frequency drives VFDS serving critical air handling units AHAS. Investigation reveals the issue occurs during scheduled generator load testing. What is the most likely root cause of this problem? A. VFDS are not properly shielded against harmonics caused by generator waveforms. B. Generator fails to supply sufficient amperage due to undersized windings. C. Transfer switch sequencing prioritizes emergency receptacles over HVAC loads. D. AHU motors exceed rated voltage during transfer switch operation. Answer. Correct answer. Explanation. Generators, especially older ones, may produce distorted waveforms that cause harmonic distortion affecting sensitive electronics like VFDS. This leads to VFD shutdowns or errors. Generator sizing B or voltage issues D are unlikely with consistent motor function outside test events. Load prioritization C explains power loss, but the selective nature of the issue points to harmonics. 430 and E519 address VFD and harmonic compatibility with emergency power. Question 4. Considering the evidence Lopez is assigned to replace a pressure transducer on a rooftop unit above the intensive K unit IQ. Before proceeding, she de-energizes the unit but realizes the disconnect switch is damaged and cannot lock in the off position. What is the most appropriate course of action in this scenario? A. Tag the switch as defective and proceed carefully, ensuring it remains in the off position. B. Notify a supervisor and delay the task until the disconnect is repaired or replaced. C. Use a secondary lockout device on the control circuit inside the unit. D. A colleague monitor the switch during the repair. There's a temporary safety measure. Answer. Correct answer. B. Explanation. According to OSHA 29 CFR 1910.147, lockout no work may be performed unless energy sources can be effectively locked out. Option B is the only one that aligns with this. Tagging alone A is not compliant. Secondary lockout C may not isolate all sources. Monitoring by a colleague D is not a valid control method under OSHA. Safety in healthcare settings is paramount due to patient vulnerability. Question 5. Among the various data gathered from a patient room complaint about discomfort, Mr. Thompson logs the dry bulb temperature at 70 Julig, relative humidity at 60%, and finds the space is reported as feeling clammy. What change would best resolve the issue without altering temperature? Increase the reheat coil output to warm the air further. B. Boost air changes per hour to increase circulation. C. Enhance latent cooling capacity of the coil by reducing chilled water temperature. D. Shift set point to 74 degrees to reduce perceived humidity. Answer. Correct answer. C. Explanation. Climate indicates excess latent heat, while temperature is adequate. RH is I. Lowering chilled water temp. C. Improves moisture removal. Reheat A. Only adds sensible heat, not dehumidification. Increasing HB could worsen humidity if outdoor areas aren't dehumidified. Adjusting set point D could reduce comfort. ASHRAE 55 addresses human comfort balance between RH and temperature. Proper latent heat control is essential in patient care zones. Question 6. When analyzing a hospital's building automation system, BAS trends Chen observes consistent mismatch between set point and actual static pressure in lab exhaust system. The PID loop appears tuned correctly, and the fan speeds are responsive. What factor should she investigate next? A. Faulty differential pressure sensors located too close to dampers. B. Software bug in the BAS scheduling module. C. Time lag in chilled water valve actuation. D. The damper actuator calibration in supply valve boxes. Answer. Correct answer. Explanation. Sensor placement A. Too close to turbulent sources like dampers can cause false readings and feedback loop issues. This leads to poor pressure control despite proper PID tuning. Software scheduling B. Affects time of operation, not loop accuracy. Chilled water valves. C. Affect temperature, not static pressure. Supply dampers. D. Don't control lab exhaust. ASHRAE Guideline 36 emphasizes correct sensor placement in high-precision environments like labs. Question 7. From a practical standpoint, Mr. Oliveira is installing a new ducted return grill in a surgery prep room located adjacent to a central medical gas chase. Which of the following considerations is most critical to ensure compliance and safety? Ensure that the return grill does not induce negative pressure in the gas chase. B. Position the grill directly across from the gas valves for visibility. C. Install a plenum damper to isolate airflow in case of gas leak. D. Confirm that the return air path bypasses the chase entirely. Answer. Correct answer. D. Explanation. NFPA 99 prohibits return air from passing through or being drawn from spaces housing medical gas systems due to explosion risk. Option D ensures compliance. Avoiding negative pressure A isn't sufficient alone. Visibility B is unrelated. Dampers C don't eliminate the hazard. This reinforces safe air handling design near combustible or sensitive utilities. Question 8. The development of a hospital maintenance plan includes routine testing of steam humidifiers serving isolation rooms. Mr. Singh finds the humidifier drain valve failing to close fully after blowdown cycles. What long-term risk does this pose? A. Excess pressure on the steam header. B. Continuous humidity injection leading to mold growth. C. Energy inefficiency due to re-evaporation. D. Inability to maintain RH during peak winter demand. Answer. Correct answer. B. Explanation. A failing drain valve causes unintentional humidification, especially during off cycles. This results in elevated moisture levels, potentially leading to mold or microbial growth in sensitive areas. Mold is a major infection control concern in hospitals. pressure and energy waste. C. A secondary winter performance. D is unrelated. Continuous monitoring is advised by HRConquer operation guidelines. Question 9. While examining the design review for a new oncology wing, Mr. Ramirez notes that the current air handling design provides only 4 air changes per hour to patient rooms. What is the correct response? A. Approve the design. Oncology rooms do not require high H. B. Recommend an increase to at least 6 inches per ASHRAE 170. C. Suggest reducing H to save energy. D. Replace mechanical ventilation with operable windows to increase air movement. Answer. Correct answer. B. Explanation. ASHRAE Standard 170 mandates a minimum of 6 inch for patient rooms in healthcare facilities to maintain acceptable indoor air quality and infection control. Oncology rooms, while not as house immunocompromised individuals needing enhanced air turnover. Options A and C are non-compliant. Operable windows. D. Violate infection control standards. Compliance ensures reduced airborne contaminants and meets FGI guidelines. Question 10. To illustrate this point, James is tasked with balancing an HVAC system in a sterile compounding pharmacy. After completing airflow measurements, she discovers that one laminar flow hood is receiving 20% more airflow than specified. What is the most appropriate adjustment? A. Close the upstream damper completely to reduce flow. B. Adjust the terminal unit airflow set point in the bus. C. Install a HEPA filter with higher resistance. D. Use manual balancing dampers to proportion flow across all hoods. Answer. Correct answer. D. Explanation. Balancing dampers. D. Allow proportional distribution while maintaining system design parameters. Sudden closure. A. Causes disruption. Bus set point. B. May affect multiple zones. High resistance filters. C. May impact particle capture rates. US 797 and ERS 800 stress laminar consistency for sterile environments, making precise balancing critical. Question 11. Through the lens of system diagnostics, Mr. Blake is called to an isolation ward after nurses report warm conditions and stale air. His analysis finds the return fan operational, filter changed last week, and chilled water valve open to 100%, yet supply temperature remains at 78 degrees. Further investigation reveals chilled water delta T across the coil is less than 2 degrees. What is the most likely root cause? A. Faulty return air temperature sensor is overriding supply commands. B. The chilled water coil is internally fouled, limiting heat transfer. C. The BAS has locked the coil valve due to maintenance override. D. The AHU is operating in economizer mode without sufficient outdoor air. Answer. Correct answer. B. Explanation. A low chilled water delta T and high supply temp suggest poor heat transfer, most likely caused by coil fouling. B. This is common in hospital environments where air cleanliness is crucial. Sensor faults, say, wouldn't explain poor delta T. Maintenance lockouts. C. Usually show up in BAS logs. Economizer mode. D. Wouldn't result in this condition if outdoor temps are high. ASHRAE 90.1 and healthcare best practices highlight coil cleanliness as essential for energy efficiency and comfort. Question 12. The effectiveness of infection control in a burn unit heavily depends on consistent airflow and pressure relationships. During a quarterly assessment, Mr. Patel finds that 2 adjacent patient rooms show identical pressure readings to the corridor, despite the BAS indicating one should be positive and one negative. What is the most appropriate next step? A. Recalibrate room pressure monitors to match BAS set points. B. Inspect door seals and undercuts to verify physical containment integrity. C. Reprogram the BAS control sequence to increase airflow differentials. D. Increase exhaust CFM in the negative pressure room only. Answer. Correct answer. B. Explanation. Identical pressure readings in opposing pressure rooms suggest air leakage or loss of envelope integrity. B. Common causes include poorly sealed doors or missing undercuts. Recalibration A. Only masks the issue. Reprogramming airflow. C. D. Is premature without confirming physical barriers. ASHRAE Standard 170 emphasizes that pressure relationships depend not only on airflow but also on room sealing for performance and containment. Question 13. In summary of a facility expansion, Franklin is overseeing HVAC commissioning of a new neonatal intensive care unit NICU. During airflow balancing, she finds that several diffusers show high velocity but lower than specified CFM. What does this most likely indicate? A. The supply ductwork is overpressurized, forcing air past the diffusers. B. The diffusers are undersized for the system's static pressure and flow rate. C. The valve terminal box is modulating erratically due to sensor failure. D. Return grills are oversized, reducing supply draw into the space. Answer. Correct answer. B. Explanation. High velocity with low flow typically signals undersized diffusers. B. Which restrict air volume but increase exit speed. Overpressure A. Would increase flow, not reduce it. Terminal box modulation. C. May vary airflow, but wouldn't sustain low CFM. Return grill sizing. D. Affects balance, not direct velocity at the diffuser. ASHRAE's commissioning guides call for properly matched outlet devices to ensure comfort and efficiency, particularly in sensitive NICU areas. Question 14. The traditional approach to service record keeping in a hospital environment is evolving toward digital compliance systems. During an audit, Mr. Edwards is questioned about a month-old service event on an or pressurization alarm that he verbally communicated to the nurse manager but failed to document. What regulatory risk does this present? A. Violation of ASHRAE 90.1 maintenance reporting requirements. B. Non-compliance with OSHA equipment service log directives. C. Breach of CMS and Joint Commission documentation requirements. D. Incomplete FGI Form 12-year post-installation checklists. Answer. Correct answer. C. Explanation. In hospital settings, Centers for Medicare and Medicaid Services, CMS, and the Joint Commission require thorough and traceable documentation for all environmental systems impacting patient safety, including HVAC. Failing to log C. Pressurization alarms can be deemed a breach. ASHRAE 90.1a focuses on energy. OSHA B pertains to personnel safety logs, not environmental control. FGI D applies at project completion, not maintenance. Proper record keeping ensures accountability and patient risk mitigation. Question 15. While it is true that hospitals must ensure redundancy in critical systems, Mr. Cheng discovers during a risk assessment that the pharmacy cleanrooms OHU lacks N+1 redundancy for its supply fans. The pharmacy director insists that downtime would never exceed 1 hour during fan replacement. What should Mr. Cheng recommend? A. Schedule quarterly emergency drills to prepare staff for temporary shutdowns. B. Install manual bypass dampers to allow airflow from adjacent units. C. Recommend upgrading to redundant fan arrays to ensure continuous service. D. Propose use of portable HEPA units during fan downtime. Answer. Correct answer. C. Explanation. Per USB 797 and USB 800, pharmacy cleanrooms must maintain environmental control continuously to preserve sterile compounding integrity. Therefore, redundant fan systems C are essential, drills A, and portable filtration D are stopgaps, not solutions. Bypass dampers B could compromise cleanroom classifications. Risk management in these zones prioritize uninterrupted system performance. Question 16. From multiple perspectives, energy savings in hospitals must not compromise patient safety. Mr. Silver proposes reducing overnight airflow to unoccupied operating rooms by 40% to reduce energy use. What condition must be met to implement this plan without violating regulations? A. Maintain minimum of 15-inch and positive pressure at all times. B. Shut down airflow completely during closed hours with HEPA filtration standby. C. Use carbon dioxide sensors to trigger ventilation on occupancy. D. KRH below 30% to inhibit microbial growth during low air periods. Answer. Correct answer. Explanation. ASHRAE 170 and FGI guidelines allow for setback airflow modes in unoccupied ORs, but still require a minimum of 15-inch and positive pressure to protect sterile environments. Complete shutdown B is non-compliant. Co-sensors C are useful for demand ventilation, but occupancy alone doesn't dictate or standards. RH below 30%. D risks electrostatic issues and is not the main control parameter. Safety and infection control take precedence over energy savings. Question 17. When presented with a regional power grid outage, ISTA Molina must coordinate HVAC continuity for critical spaces in a hospital. The emergency generator supports only 60% of total load. Which area must he prioritize for continuous HVAC service? A. Administrative offices for coordination and communication. B. Cafeteria for food preservation and staff nutrition. C. Operating rooms and isolation suites for life safety and infection control. D. Visitor lounges to maintain public perception and comfort. Answer. Correct answer. C. Explanation. NFPA 99 and NEC 700 require emergency systems to prioritize critical care areas like HVACs and isolation rooms for HVAC continuity. These zones directly impact patient survival and infection control. Admin and support areas A, B, D are low priority and can be managed via contingency protocols. HVAC professionals must understand load prioritization under emergency conditions. Question 18. According to recent studies, White is integrating a new valve system into the hospital's existing BAS. During functional testing, she finds that several zones are slow to reach set point even though the terminal boxes report correct damper positions. What should she investigate first? A. Calibration of zone temperature sensors. B. Static pressure sensor feedback loop settings. C. Minimum position settings of valve dampers. D. Supply air temperature override lockout. Answer. Correct answer. Explanation. If the damper responds but temperature doesn't match sensor miscalibration, there is likely issue resulting in improper readings that affect control logic. Pressure sensors. B. And supply air temperature. D. A system-wide and would affect more than a few zones. Minimum damper settings. C. Control ventilation but not zone response. BAS performance in hospitals depends heavily on accurate feedback and sensor integrity. Question 19. With respect to maintaining patient safety, ISTA Cooper performs a ventilation check in a radiology room. The room houses imaging equipment that generates excess heat and has shielded walls. Despite high cooling airflow, technicians report persistent hot spots. What system design factor is most likely responsible? A. Supply diffusers are placed directly above equipment, short-circuiting airflow. B. Radiant heat from equipment is not offset by convection cooling. C. Return air path is blocked by the room's lead-lined walls. D. Thermostats are located too far from the heat sources. Answer. Correct answer. C. Explanation. Lead-lined walls in radiology rooms often block return airflow if duct design doesn't account for shielding. C. Creating stagnant hot zones. Short-circuiting may reduce mixing but wouldn't cause persistent heat zones. Radiant convective mismatch. B. Plays role but is less critical than return path failure. Thermostat placement. D. Can skew readings but not airflow. ASHRAE design guides stress the importance of ventilation effectiveness in shielded rooms. Question 20. The prevailing attitude toward interdisciplinary communication emphasizes collaboration. ISTA-NG receives a complaint from ICU nurses that the supply air feels drafty over patient bed. Upon inspection, airflow meets design specs. How should he proceed? A. Explain the airflows within spec and no action is needed. B. Recommend that nursing adjust patient bed positioning instead. C. Work with clinical staff to reposition diffuser or add deflector. D. Suggest increasing return airflow to reduce supply draft. Answer. Correct answer. C. Explanation. Although airflow may be within design, patient comfort is paramount, especially in ICUs. The best approach is collaborating with clinical staff. C. To modify diffuser direction or add a deflector to resolve draft complaints. Ignoring a shifting burden to staff. B. Or adjusting returns. D. Without solving draft direction is ineffective. Good communication builds trust and ensures patient-centric outcomes per health. HVAC with best practices. Question 21. The core principles of thermal regulation are vital in surgical suite design. Mr. Walters is investigating why an OR maintains the correct temperature set point, yet surgical staff report discomfort and temperature swings near the operating table. All sensors, fans, and BAS logic appear functional. What is the most likely issue? A. Poorly placed supply diffusers are creating uneven radiant temperature zones. B. Return grills are oversized, creating excessive suction around the table. C. The supply air temperature sensor is located too close to the heat coil. D. Floor-level stratification is causing cold spots below staff sensing height. Answer. Correct answer. Explanation. Even if air temperature meets set point, improperly located diffusers can cause radiant heat imbalance, impacting thermal comfort near surgical sites. This is especially critical in ORs where ASHRAE 170 mandates specific supply locations. Oversized returns B wouldn't create perceived temperature swings. Sensor location C may skew readings but wouldn't explain spatial variations. Stratification D affects large rooms but is rare in well-mixed or airflow. Question 22. Upon closer examination, NASA is inspecting a rooftop unit serving an ICU. The system reports low suction pressure, slightly subcooled liquid at the condenser outlet, and high superheat at the evaporator. What does this data most likely indicate? A. The expansion valve is stuck open, causing floodback. B. The system is overcharged and liquid is backing into the compressor. C. There is a refrigerant undercharge or restriction at the metering device. D. The condenser is excessively fouled, raising head pressure. Answer. Correct answer. C. Explanation. Low suction pressure plus high superheat plus normal subcooled liquid indicates either a refrigerant undercharge or flow restriction. C. Overcharge B would raise suction pressure. A stuck open TXVA would decrease superheat. Foul condenser D increases head pressure, but suction side remains unaffected. Proper charge ensures reliability, and hospital HVAC are serving critical areas like ICUs per ASHRAE guidelines. Question 23. From a historical standpoint, HVAC technicians often encounter nuisance trips in GCI circuits. Mr. Ellis is replacing a fractional horsepower motor in a patient room exhaust system and notices that every time the motor starts, the GSEI breaker trips. What is the most likely cause? A. The motor insulation resistance is too high, triggering false leakage. B. The motor's immersed current exceeds the GFCI trip threshold. A. GSEI protection is not compatible with variable frequency motor loads. D. The motor's winding impedance is inducing backfeed into the circuit. Answer. Correct answer. C. Explanation. GS is often nuisance trip when used with VVF-DS or motors that produce harmonic noise or leakage currents outed GSEI tolerance. C. This is a known compatibility issue. Inrush current B causes breaker trips, not GCS-specific ones. Insulation resistance A is irrelevant. Winding impedance D would not affect GFCI. NEC 210.8b allows exceptions in certain hospital settings where GFCI trips threaten life safety. Question 24. The implications of improper ventilation in the Central Sterile Processing Department ECCD can result in widespread contamination. During commissioning, Delgado notices the exhaust airflow is equal to the supply airflow. The room has sealed cabinetry and negative pressure is required. What is the proper corrective action? A. Reduce the supply airflow to create a negative offset. B. Increase exhaust flow to exceed supply and maintain pressurization. C. Add return grills to improve mixing. D. Raise the static pressure set point to increase it. Answer. Correct answer. B. Explanation. To maintain negative pressure per ASHRAE 170, exhaust must exceed supply. B. Matching airflow nullifies pressure differential. Reducing supply A can cause comfort or filtration issues. Return grills C belong in neutral or positive pressure areas. Static pressure D impacts delivery, not differential. Proper offset protects sterile equipment and personnel from airborne contamination. Question 25. Examining the consequences of PID tuning errors, Mr. Harper finds a patient isolation room alternates between slightly positive and negative pressure every 510 minutes. The BAS shows the exhaust fan speed varying rapidly. What is the most appropriate adjustment? A. Tighten the PID loop gain to improve response time. B. Widen the proportional band and increase integral time for stability. C. Disable automatic tracking and switch to manual override. D. Increase the supply airflow to overcome exhaust variability. Answer. Correct answer. B. Explanation. Rapid fluctuations suggest an overly aggressive PID loop. Widening proportional band and increasing integral time. B. Slows the response and prevents oscillations. Tightening gain A. Worsens instability. Manual override. C. Sacrifices control and is non-compliant. Increasing supply. D. Doesn't address root cause and can reverse pressure. ASHRAE control guidelines promote tuned PID loops in critical pressure-controlled zones like isolation rooms. Question 26. Throughout the course of routine balancing, Mr. Smith notices that a negative pressure wound therapy room occasionally reads zero pressure difference when adjacent doors open. The room otherwise performs well. What is the best action to ensure consistent pressure control? A. Increase door closer speed to minimize pressure drop during entry-exit. B. Install a pressure booster fan in the exhaust line. D. Add a vestibule or anteroom to isolate pressure swings. D. Set exhaust to ramp up only during patient procedures. Answer. Correct answer. C. Explanation. Vestibules or anterooms. C. Act as buffers, maintaining negative pressure during door activity. This is especially critical in wound care areas. Adjusting door closers. A. Is not reliable. Booster fans. B. Can cause instability. Ramping exhaust only during procedures. D. Creates periods of vulnerability. Per ASHRAE 170 and infection control protocols, architectural solutions are superior to purely mechanical fixes for air containment. Question 27. To what extent does ventilation impact safety in medical gas storage? During a review, Mr. Foster notes that the medical oxygen storage room has passive vents and a 6-exhaust fan that runs intermittently. Is this setup compliant? A. Yes, as long as the room temperature remains under 7 Tidec. B. No, the exhaust must run continuously and be vented outdoors. C. Yes, if the oxygen volume stored is less than 300 cubic feet. D. No, the room must have pressurized filter return path. Answer. Correct answer. B. Explanation. NFPA 99 requires that oxygen storage rooms have continuous exhaust vented directly outdoors, regardless of temperature. Intermittent fans. B. Risk accumulation of oxygen and fire hazards. Temperature limits. A. Are not adequate controls. Storage volume. C. Determines occupancy classification, not ventilation needs. Return air. D. Is prohibited in medical gas storage. Air must exhaust completely. Proper ventilation reduces combustion risk in medical environments. Question 20. The most significant aspect of maintaining proper air quality in bone marrow transplant units is pressure and filtration. Rivera notes the pressure is correctly positive, but visible particles are found near the ceiling. What is the most likely cause? A. The HEPA filter damaged or improperly installed. B. The return airflow is too strong and pulling air from adjacent zones. C. The supply diffusers are overpressurized, creating turbulence. D. Occupant activity is resuspending settled particles. Answer. Correct answer. Explanation. HEPA filters are critical in immunocompromised zones like BMT units. Damaged or loose filters allow particulates to pass. Strong return airflow. B. Affects pressure, not necessarily particle release. Turbulence from overpressurized diffusers. C. Is secondary. Occupant activity. D. Would resuspend particles lower in the space, not near ceiling. ASHRAE 170 mandates effective filtration and positive pressure to protect vulnerable patients. Question 29. One might argue that core cleaning isn't urgent unless airflow drops. However, Mr. Green discovers biofilm on chilled water core serving pediatric ward. What is the most significant risk of delaying cleaning? A. Reduced temperature control in adjacent zones. B. Mold propagation and airborne contamination. C. Corrosion of fin stock and copper tubes. D. Loss of laminar airflow pattern in ceiling diffusers. Answer. Correct answer. B. Explanation. Biofilm is a microbial risk and can harbor pathogens like Legionella, especially in humid hospital zones. Delaying cleaning can promote mold and infection. B. Adjacent zone control. A. Is then likely to be directly affected. Corrosion. C. Is long-term but not immediate. Laminar disruption. D. Is unrelated to coil fouling. Healthcare maintenance must prioritize IAC, especially in pediatric, immune-sensitive areas. Question 30. A critical examination of Mr. Connor's work order shows repeated HVAC complaints in behavioral health unit, yet no trend analysis or root cause reports have been filed. What consequence can this documentation gap lead to? A. Inefficient BAS operation due to unresolved control sequences. B. Patient complaints about comfort leading to CMS penalties. C. Regulatory audit findings due to lack of failure analysis. D. Increased mechanical wear on diffusers due to overuse. Answer. Correct answer. C. Explanation. Regulatory bodies, e.g., the Joint Commission (CMS), require root cause documentation for repeated HVAC failures, especially where occupant health is at stake. Failing to track issues, C. exposes the facility to citations. Comfort complaints, B. are indirect. Mechanical wear, D. is not relevant here. BAS efficiency, 8 matters, but documentation compliance is the legal concern.